Hello everyone, welcome back to Artificial Intelligence class. Today we are going to discuss about Unit 2. Basically, the Unit 2 contents are stacks, queues, trees and graphs introduction, general search algorithms, searching for solutions, problem solving agents, control strategies. Then we have uniformed search methods, that is uninformed searching methods, breadth first search, uniform cause search, depth first search, depth limited search and informed search. Under informed search, we have generate and test classification and best first search algorithm and A-star algorithm. And we are going to discuss all the algorithms one by one. And if you see an introduction to stack, a stack is a linear data structure that follows the LIFO order, that is last in first out principle. A stack is an abstract data type with a predefined capacity, which means that it can store the elements of a limited size. So if you can see that first element has been stored in the stack, and by using a push operation, you can just insert a second element on top of the first element. Similarly, one by one, all the elements can be stacked by using a push operation on top of the previous value. And there are several stack operations: push, pop, is empty, is full, peek, count, change, and display. Working of a push. How the push will be operated is, first it will be empty so that the top value will be having a -1. And if you want to push a value of a 10, then the 10 will be pushed and the top will be incremented by 1 so that the new top value will be 0. Then again, if you want to push 20 on top of 10, then the top value will be incremented by another 1, so it becomes from 0 to 1. And also the push value of 20 has been pushed into stack on top of 10. Similarly, if you want to push the next element, the top will be incremented as we have seen so far, and the value of a push also will be pushed onto top of a 20. Similarly, if you want to push 40, what will happen is top will be incremented to 3 and the value of a 40 will be added on top of a 30. This is how the values from 10 to 40 will be pushed onto the stack. Once all the values are pushed onto the stack and the stack becomes full. How the working of a pop is, if the stack is a full, okay, by using a pop operation, we can able to remove the elements one by one from the stack. So by using a pop, you can able to remove the elements from the top of the stack one by one. So when top is equal to 3 initially, which means that the stack is full. If there are 4 elements, the top will be what? 3 value is updated on top. So when the value of first is being popped out of the stack, then top will be decremented by 1 and its new value will be 2 and the value of 40 will be out of the stack. Similarly, for each and every element removal from the stack, the top value will be decremented by 1 each and every time. Finally, if all the elements have been removed, the top will be updated as -1, which means the stack is empty. These are the applications of a stack: balancing of symbols, string reversal, undo, redo, regression, depth first search, backtracking, expression conversion, memory management. We'll see next about a queue. Queue is referred to be as first in first out list. For example, people waiting in line for a rail ticket form a queue, right? Similarly, the people waiting for a lift, they'll be forming a queue. They are the examples of a queue. If you see the queue operation, it will be having a DQ and NQ, which means NQ is insertion operation and DQ is deletion operations. So the queue will be operated with these two kinds of operation called NQ and DQ. So always you have to enter via this NQ and exit via DQ. And this entry will be called as a rear and the DQ will be called as a front. So some of the applications of a queue, queues are widely used as waiting list for a single shared resources like a printer, disk, and CPU. Queues are used in asynchronous transfer of data, where data is not being transferred at the same rate between two processes. For example, pipes, file, I/O, sockets. Queues are used as buffers in most of the applications like MP3 media player, CD player, etc. Queue are used to maintain the playlist in media players in order to add and remove the songs from the playlist. Queues are used in operating systems for handling interpret operations. And the types of queue, we have got various types of a queue. They are simple queue or a linear queue, priority queue, circular queue, double encoded queue. That is double-ended queue. Operations in a queue: NQ, DQ, peak, queue overflow. It is also called as is full. Over underflow queue is also called as is empty. Introduction to trees. A tree data structure is a non-linear data structure because it does not store in a sequential manner. It is a hierarchical structure as the elements in a tree are arranged in multiple levels. In the tree data structure, the topmost node is known as a root node. Each node contains some data and data can be of any type. In the above tree structure, the node contains the name of the employee, so the type of data would be a string. Each node contains some data and the link of references of other nodes that can be the children. Types of trees. We have got several types of trees. Binary tree, binary search tree, AVL tree, red black tree, splay tree, and B tree. Introduction to graphs. So we have got two major classifications of a graph: a directed graph and undirected graph. Graph can be defined as a group of vertices and edges that are used to connect these vertices. A graph can be seen as a cyclic tree where vertices, which means nodes, maintain any complex relationship among them instead of having parent-child relationship. Graph technology. There are different technologies in a graph. They are listed as here: path, closed path, simple path, cycle, connected graph, complete graph, weighted graph, loop, adjacent node, and degree of a node. Deriving adjacency matrix for graphs. So if you have a graph with nodes of 5 from A to E, then how we can form a matrix for this particular graph is list all the nodes from row wise and column wise. So column wise A, B, C, D, E is been listed, and similarly for row wise A, B, C, D, E has been listed. So if there is a connection between A and B, you just mark on A and B as 1. If there is no connection, then mark it as a 0. Similarly, if you fill this based on this links and a connectivity, if you fill all the matrices here with respect to 0 and 1, the matrix of a graph will be completed. In general search algorithms, searching is the process of finding some particular element in the list. If the element is present in the list, then the process is called successful and the process returns the location of that element. Otherwise, search is called unusual, unsuccessful. Two popular search methods are linear search and binary search. So if you see the binary search, if the target is a 9, it starts searching from 1, 2, 3, 4, 5, 6, 7, 8, 9. And similarly, if it is a linear search and it is if the target is a 9, it starts searching from 1, 2, 3, 4, 5, 6, 7, 8, 9. This working of linear search, the value of a k, that is 41. The value of a k here is, suppose assume it is a 41, is not matched with the first element of the array. So first element of the array is 70. So move to the next element and follow the same process until the respective element is found. Which means, suppose if your element is, your target element is a 41, if you want to reach the 41, you start searching from the first element. So initially the first element has got the value as 70, which is not matching with the target element 41. So what you have to do is you have to keep moving the array from first element to next element, and similarly it should be kept on moving until the target element 41 has been found. Once it's been found, you can stop searching it. And if you see the binary search, search the number 7 in the array. So suppose if you want to search the number 7 in the array, first you have to calculate a mid value in a binary search. Linear search works from the starting to end. Yes, searching will be starting from the first element till the target element. For a binary search, first we have to find mid value of the entire list. So here the mid value will be 5. Okay, so your target element is 7, means first find out that 7 is greater than 5 or not. So if 7 is greater than 5, then you have to consider right off. So from the right off, from the fifth element, if you start searching towards the right, then it becomes a binary search until finding the target. If suppose your target element is less than 5, for example, if it is 3, so from the center you have to start searching towards the left until you are finding the target. This is how the binary search will be working. Next, we'll discuss about general search algorithms in the next class. Thank you for watching.